Trying to record. Okay, so uh, today the plan is I will show you some of the graphs which I have made, and then you will tell me which one looks good, which one looks bad, and then we'll discuss why it's good or why is it bad. Hopefully we'll finish by time so Arhan can go on time. So let's start. Okay, so I have made everything in Inkscape. So I think some of you might be familiar with interface. Okay. Okay. Yeah. So first thing to discuss, whenever you make a graph, we have a choice, right? We can choose serif and non-serif font. Anyone knows what is serif font and what is non-serif font? Okay, who is? You raise your hand and speak. Who is speaking? Okay. Yeah, raise your hand and speak. Calibri is non-serif, yeah, sans serif. What do you mean by serif and non-serif? Do you know this term or no? Huh? 3D projection. No, no, no. Everyone knows Times New Roman font, right? So this is very similar to Times New Roman. I think this is slightly different. But what is the main difference you see between this font and this font? Huh? Brightness. Okay, I see a lot of answers. Uh, okay, the size is a bit different. Let's forget about the size. This is a bit bigger. Anything other than size, you see difference. Huh? Yeah, so I think Saddam is very close. He is saying if you look at a font type, the width or the thickness is uniform for all the alphabets here. But here it's different, right? So why it's thicker here, thinner here, and at the tail it's thicker, and at the cap it's thicker. So if you have any font which is of this type, it's called serif font. So serif is with all the decoration. So if you have all this A and all the thick and thin line, it's called serif. Any font which when you don't have these changes in thickness, it's called sans serif, which means without serif, without the decorations. This is English. Maybe it's Latin or something. I also don't know. But this is English. Yeah, so everyone understood the difference? Okay, so my next question. Which font is suited for presentations? Huh?
For the titles, the one on the right, and for the details, the one on the left.
Okay, so how many of you say, okay, let's say for main content detail, if you have a plain text in your presentation, how many of you say this font is good? Raise your hand. Okay, raise your hand fully. And how many of you say in general text this font is better? Huh? Okay, so people who said this one, why do you think this font is better? Looks appealing. Okay, any other argument? Huh. Any other argument? And people who said this, why do you choose this? Huh? Better for you, better for people who have glasses. Okay. So, huh? Oh, okay. We can see from backside. So if I think it's not noticeable from bit far, but usually when we use fonts in presentation, we have to use a projector, so we'll have some pixelation. So maybe it's not that visible from far, but if you come closer or if you are at my distance, I can see every pixel. So with pixelation, this font will not look that sharp many times. This projector is still decent, but if you have slightly low quality projector, your font will not look very sharp if you use this. This one will still look decent because you don't have lot of decorations. So this one will look cleaner. So in presentation, most of the time, with some exceptions, most of the time you stick to sans serif font. So any example of sans serif font you know? Calibri, okay. Any other font? Arial, yes. Any other font? Yeah, I think most common is Calibri or Arial. And I think people who use latex, there is one famous font called Helvetica. I think that's how it's pronounced. That is also very common. So these are some examples of sans serif font. And serif font Times New Roman, I think everyone knows. Then there are Garmin and other things. Most people use Times New Roman. So if this font has problems with seeing it, why is it used?
Papers,
Huh?
printing on the papers.
Can you explain?
When we are making a report, right?
Huh?
Ink is used.
So it's not done like in the presentation manual.
Hmm.
So they have to print on the paper and
Hmm.
it is used.
Yeah, so that's right. If you have to read anything on print, in print form, this font is better because you don't have to read the full alphabet. Looking at the shapes, you can distinguish the alphabet. So when you are reading a word, you don't have to see all the lines because there are some thickness variations. You can guess from back of your head, okay, this is Y, this is E. So for print form, that font is better. But for presentation form, this font is better. So is that clear? So when you make your presentation in this course or in your life, make sure you use right font. So that is for printing, this is for presenting. A lot of people are not so sure, so I thought I should start with this thing. Then, yeah, so any difference you see between these two graphs? Huh?
Axis marking and axis.
Darkness is same. Darkness is same. Yeah, darkness is same. Anything, any difference you see? Pixel. Huh? Okay, yeah, this marking, okay, it was my mistake. Anything other than this, anything other than that? Font style. Who said font style? Where? What is the difference? Font size of the axis. Okay, so, okay, do we all agree this font is different? So which font is serif, which font is non-serif, sans serif? This is sans serif, right? So which one is easy to read? That was big, so it was easy to distinguish. But here, which font is easier to read? Right, right?
And also ANR
Also what? ANR?
is missing on line.
It's here, right?
No, in the last, third line.
Okay, okay. Okay, that was my mistake. But I think you get the idea. So if you have smaller font because of pixelation, this the text here will become more blurry. This, so that was bigger font. Here it's font is smaller in size. So here you can see the distinction. This one is still easier to read compared to that. So, so what is the conclusion? When you make plots, data charts or anything, your font will be smaller than your regular text. Then this will become even more evident that okay, which font is better where. So I think a lot of people still use that font, but make sure you use sans serif. So you use sans serif for the labels, the title of the axis, and also the legend, everything.
While printing as well? Or?
For printing, you can use that, but for presentations, use this. And if you ask about journal publications, if you are publishing your graph, then because journal publication is seen in both print and digital format, so most people will still recommend this because now most things are becoming digital, so this one is still preferred. So if you look at any guidelines from say big journal houses like Nature, Science, they will say you have to use this font or you have to use sans serif, otherwise they'll reject your paper straight away. So they'll say no, if the font is not right, you are not following the guidelines, it's not, so they will not accept it. So is that clear? Okay, so let's go to the next thing. Yeah, what do you see the difference here? Yeah, the difference is you cannot see anything there, right? So when you make your figure, I think this is the most common problem like researchers, like MTech PhD students have, is very often your font size will be very small. So like maybe you guys are young, so your eyes are good, but if you show it to an old person or say a 60-year-old supervisor, how do you expect him to read that? So when you are making your plots, how will you know what is the right font size? How will you decide? Yeah, you can take reference, but when you are making your graph, when you are plotting it wherever you are plotting, let's say Excel, and then you have the final figure, how will you know the font size is correct when it's on presentation or in your thesis, let's say? How will you judge the font size? Huh?
Same as font size of the board.
Same as what?
Font size of the board.
Font size of the board
Report.
report. How will you judge that? Even if you, let's say, you keep your font size, let's say your report font size is 12, but you also use font size 12 here, but then you shrink your plot. When you use it in your thesis, you shrink it. Then the font size will reduce, right? Yeah, so this is the rule I follow. It's not thumb rule. So if you make any figure in scalar format, let's say JPEG or PNG or whatever, you check the font at 100% zoom. So it should not be 120% or 150% or 50%. Check your font at 100% zoom. So let's say you put in PowerPoint and then you can see at the bottom right corner, like zoom. You will also have zoom in most softwares here, right? So at 100% zoom, this should be readable. So that is for, let's say, printing or thesis. But for presentations, it's slightly bit tricky because you will show it in your full screen, so you will see zoomed view when you see presentation. So in your computer or laptop, when you have your graph, make your presentation full screen and step 1 meter away and see if you can read it or no. So that is, so in your laptop, of course, it will be smaller, so 1 meter should be enough. So when you show it to a bigger audience, then it should more or less cater to the distance. So is that clear? So when you are making plots for printing, make sure you can see everything when zoom is 100%. So that will be true size. For most softwares, it's correct. For softwares like Inkscape, you have to manually change it a bit. But make sure you know the right size, 100% zoom, and then you see the font size. Can you read it or no? And for presentation, make your presentation full screen and step at least 1 meter away and then are you able to see, are you able to read your font or no? So this is most common problem. So when you make your plot in your say, laptop or PC when screen is small, you cannot judge. So finally, when it comes to presentation in a big projector, it's very hard to see is my font correct size or no. So is that clear? Okay. So what do you see? Do you see any difference between these two figures?
The plots have different width of.
Okay, the line width is written here, but where do you see the difference? Which lines are different?
Red, black, and
Hmm?
red, black, and
Yeah, Neha, what are you saying? These lines. Yeah, so you can see, right? The plots here are thicker. Anything else? Or that's the only thing? The box line is also thicker, right? Okay, yes, box line is same in this. Yeah, so this is the major difference. So all the lines here are thicker. So for presentation, which plot will you prefer? Left or right? Okay, how many of you say left? Raise your hand. And how many of you say right? Raise your hand. Yeah, so people who said left, why did you think left is better?
That doesn't make any difference.
Will
It's
close by will be
just a
easily
curve,
visible.
right?
Huh?
Just a curve, right? We'll just see the trend of the line.
Yeah, that's correct. But will you choose this thickness or that thickness when you are making, let's say you are making this plot?
the intersection is more clear.
Intersection is more clear in the thin one. Okay, and what about this?
Right.
So it's uniform. Outer line and inner graph are in the same font. So it's uniformity of the font.
Okay, so Saddam is saying this thickness and this thickness are same. Hmm.
If there are small curves or bends over
Hmm.
very small distances,
Hmm.
then if the line width is thicker, those curves will not be clearly visible.
Hmm.
That's why the one on the left should be used.
Also, these curves from the data points.
Hmm.
Data points are like
There are if data points are large in number,
Hmm.
then the one on the left should be used.
Large. You mean many data points?
Yes.
Okay. Yeah, so what about this? Okay, for some other graph, maybe what you are saying is correct, but what about this? It's a simple plot, it's a TGA plot. So, which one do you think is better? Think of a 60-year-old professor, then you make your answer.
That is what we.
This one.
Yes.
Yeah, so if you think about old people, then then most likely you will choose this because that font is a bit thin. That line width is a bit thin. So of course what Arhan said is correct. So if you have lot of data points, you cannot use very thick line because then you will lose your resolution and you cannot see the data clearly. So you have to reduce your line thickness little bit. But then you have to also increase your graph size. If your graph has to say a lot of things and you cannot show it properly, then you make it bigger. But always try to make your graph line widths thicker. Otherwise, you cannot see it. Or maybe you can see it, we cannot see it. So that's the problem I see in a lot of presentations even here. Like a lot of people have very thin. So this one is still okay, but I have seen graphs where even I cannot see what is the data plotted. So is that clear? Why we should use a thicker line?
But sir, if more than three curves, like if number of curves are greater,
Hmm.
so if the lines are thicker, then it may be chances of the overlap.
Yeah, so as I told, so if you have lot of data, then make your plot bigger. If you
For the 60-year-old professor, how can he make it visible?
How can what?
How can we plot those plots for them to see proper? We can increase scaling.
Yeah, you increase the scale or you make multiple plots. If you have lot of data, don't choke your.
Only a single plan, a single plot.
I think if you choke your data in one plot, nobody can read it. So if you have lot of data, if possible, make multiple figures. If you still have to use one plot, make the plot at least bigger, so you can see with better resolution. Is that clear? Okay, so let's go to the next plot. Yeah. Okay, so here I think I could not do it in the last box, but here you can see the box line is thinner or thicker than the plot lines? Thinner, right? So which one do you prefer? The this one or this one?
Bottom one.
Okay, who says upper one? And who says bottom one? And what about other people? Every time that number never adds up. Okay, so people who said this one, why do you think this one looks better than that one? Let's make it clarity. Okay, and people who said the smaller one, thinner one, why do you think this one is better?
The points were there.
Huh?
The points from which the curves originate, those can be more clearly seen.
Okay, Raghav, what were you saying?
Sir, box does not contain any information, sir.
Hmm.
So make it thinner will be.
Hmm.
The point of origin of the curves.
Sir, here is eye deflecting means he can see graph clearly but not the reading. So how can that means where is
You can see the graph but not the reading, this one.
Reading same.
means
Reading font, okay, let's say, okay, it's same to me, but okay, let's say the reading font is not that small. The only change we see is the box border thickness. So what will you say then?
whole focus is going on the just that line means if you
Hmm.
Just on the graph lines we can focus.
Hmm.
Rest borders and
Not
numbers
required.
Hmm.
we are not able to focus clearly. But in that borders, numbers, all are good.
Reading wants focus on that.
Yeah, so,
More easier to read.
huh?
It's more easier to read.
Okay, so I think this time, this plot, maybe in projector it's not that evident, but if you, like some of you pointed out, if the border thickness is very thick, your first eyesight will go on the box, or if the thickness is same, you will see the box borders and the lines in the same focus, like with the same priority. But if you have line thinner in the box but thicker at the plot, you will, your first instant will be to see the plot lines.
Also, sir, highlighted border always insists to focus on that particular graph area.
Highlighted border?
Highlighted border,
Huh?
it focuses more focused on the middle part, like graph part.
Hmm.
If border will be highlighted, then it will be good to focus on that particular curve. Because if it highlights the main
Hmm.
border, it gives you a close area. Yes, sir. That this is a graph.
What?
It gives you a close area to focus.
Is this not closed?
It's close, but in contrast of the thickness,
Hmm.
it doesn't feel like it's close.
What is the answer?
Yeah, so the answer is you can make your borderline thinner, but it should still be visible. Don't make it open. So as long as you have border thickness which is visible to eye, but it doesn't grab your attention before your line thickness, that is the best choice. But if you make everything thin, what's the problem? This looks very ugly, right? Yeah, because you cannot see anything. So if everything is thin, like this is the worst choice. This is good, that is also decent, this is also good, but this is worst choice. So here you cannot see anything. And I think you will see a lot of, if you sit through Compre or SOTA, you will see this a lot in IIT Kanpur. So yeah, make sure you don't make this mistake. You make your lines at least, like if you are not if you don't want to change all the thickness, make everything thick, or if possible you can make your lines a bit more thicker than the border, but don't do this ever. हाँ? लाइन विड्थ चेंज कर सकते होंगे. So when you plot it for yourself, it's okay. But when you want to use it for presentation, publication, or thesis, make sure you don't use this plot. You have slightly better plots. Is that clear? I'm sure in MATLAB you can change the line thickness. I don't know how to do it, but there should be ways. Okay, so any questions so far on the graphs? Yeah, I have made all these plots in GNU plot. So the other software I mentioned was I think lab plot. Yeah. Huh? Yes, Saddam.
So the axis data should be have some any symmetry means boldness relative to boldness inner side graph and axis to the point like 80-70.
It is 70.
Not boundary means the number should be also in comparable way. Or
You mean the size of the number?
yeah. And there is one thing that initially you not tick all the means axis. If you tick 4 axis, so it's necessity or will be you can left it.
You mean ticks where?
upper and right axis mark.
Every axis you mark.
Okay, this one I missed. Okay.
Yeah, you not put number in right side, but you put tick it.
Okay, you are saying these numbers are not here.
But it ticked it, and initially in first slide you not tick it, means blank.
Okay, I think that was. mm okay, here there are no ticks on top.
Either upper side, either left.
It's best to put ticks everywhere. Otherwise, reading the graph on the right side becomes difficult. But if you have the numbers on left side, that is enough. But make sure you have ticks everywhere. So for example, here it's very hard to see the temperature from top. Here it's easy, right? Because you have ticks on top and bottom. So make sure you have ticks on all sides. That is better. हाँ? क्या? Grid बनाया है, but you cannot see it because of the projector. I can see it on my screen. Yeah, so if you have to be very precise on x and y coordinate, make grid. But again, grid should not distract you from the graph. So grid should be say light color, thinner or lighter color, whatever. Okay, so let's go to next thing. Yeah, now let's talk about colors. What is the difference between these two graphs? Huh? Yeah, so I heard many people saying contrast. Yeah, well, how do you define contrast? Or what is the thing which has changed from here to here? Why do you say the contrast is different? Okay, the border thing I messed up here. Yeah, anything with these three lines on both sides? Colors are different. So what is the difference in the colors? Left one is more vibrant. And right one? So can any of you think or what makes these two are same or blue, but what makes this dull? RGB is what?
RGB is used on the left side.
And this one? This is not RGB?
Yellow is derived.
Yellow is what? Okay, so you are saying it's not primary color. Okay, forget about say, okay, I messed up the color also. Okay, so what about this blue and this blue? What is the difference between the two blues?
Sir, they are starting at the initial point where the blue cut is
Yeah,
starting.
I swapped the colors accidentally. I'm asking in the color, this is blue and this is also blue. But what is the difference in the color of the blue? Huh? Intensity. Saturation, okay. So on this blue, if I mix white, will I get this? If I make it lighter, I mix white, I will get this or no? Yes or no? So I think all three, okay, yellow is off, but this red is also similar. So you mix white on these colors, you will get lighter color. Yes or no? So, okay, we'll come to the colors a bit later, but this is what I wanted to show. So you can make your colors light by adding a bit of white. Hmm? Huh? We'll come to the answer later. I'll show you some more color things. Okay, so what about this? Okay, so let's look at blue only. So I think because of projector, many of my colors are changing. But let's see the blue. So this blue and this blue, which one looks dull? Left or right? Left is dull. So how can you get that blue from here? You mix some black color in your blue, then you'll get something like that, right? Yes or no? So this is mixing black, or we call it darkening. So you can make your color light by mixing white, or you can make your color dark by mixing black. So this is what I have shown here. So which one looks good? We'll come to that soon. So I wanted to show you these are some things you have to keep in mind when you are choosing colors. Then, okay, what is the difference between these two graphs? Similar color.
Colors on the same side of the spectrum.
Okay, which spectrum? With gear. Okay, let's see this easier. Tool shift. Ah. Yeah, so if you look at the color circle, can you, okay, I messed up the graph color. Wait. Ah. Okay, so if you look at these two graph colors, what do you see any pattern when you look at the wheel? When you look at the wheel? Yeah, forget about this triangle, just look at the wheel. So this is VibGear, which is circled. So VibGear is starting at say violet again. So do you see any pattern on those colors and these colors on this ring?
Consecutive shades are
Consecutive. Yeah, so for example, let's say those three shades, all of them are near red, right? So red and brown is also a bit darker shade of red and orange. So everything is here on the left graph, everything is on this side. And on this graph everything is say somewhere here, right? Violet and say little bit of green and blue. So everything is on this shade of the circle. Yes or no? Any of you are color blind? Oh, Devansh, you are color blind?
Dark means
Huh?
Where that line in that circle.
So you have to change the saturation and lightness, then you will get that color. We'll discuss about it later. So everyone understood or no? So those shades which are near red, we call it warm shades or warm color because they are closer to say red shade or yellow shade. And everything which is clear, near to blue, we call it cooler shades. So whenever you are making your graph, make sure you have this consistency. So when you choose any color on a graph, it's best to choose all the colors near that same shade. So for the plot to look coherent or say not symmetric, say consistent. So if you have one color here, one color here, one color here, it will look say very random. But if you have three colors, all are near each other, then it will have a theme of the color. So this is a bluish like, this one is like orange or red like. So then you will not have that mismatch. Yes or no? So if I have say red here, and let's say I make this, okay, let's say this is green, and I make it red now. It looks odd, right? Because two colors are light shade, and this one is a warm shade. But this one looks, let's say, decent. This one is close to black, but yeah, all of them are say warm shade. This one is very off. So with three plots, it's not that evident, but if you have say 5 lines, 10 lines together, and you have one orange, everything else is blue, it will look very off, right? Yeah, so this is something you have to keep in mind. Make sure your color shade is consistent. Either you choose warm shade or you choose blue shade. There are some exceptions, we'll talk about it. Any questions? Okay, so let's go to this plot. Okay, so if we talked about shade, do you see any difference in these two plots? This is like rainbow. Huh? More what? Okay, which color scheme you prefer, left one or right one? Okay, how many of you say left? And how many of you say right? Okay, now you look at the legend and then decide again which color scheme will you prefer. You look at the legend. Huh? Okay, how? People who are saying right, can you tell me why you choose right? Mm.
Individual plots are easier to see.
Yeah, so
Yes, the black of the second one. That is
Also considering as an old people because if
okay, he has good point. Okay, let's say we don't want to follow the exact details, but we want to see a trend from this graph. We don't want to see, okay, where is the xy coordinate, but we want to see if the data is following any trend or no. In that case, which plot will you prefer? Left, right? Because the color scheme is more or less explaining that, okay, when you go say, when you, let's say, increase this ratio or decrease this ratio, whatever, you go from say orange to black. So from orange to black, this curve is shifting left, this curve is shifting left, something like that. But here it's a bit hard to follow that, right? So if you want to make your plots look distinct, you will choose this. Or let's say you have 60-year-old professor, then you will choose this. But if you want to show a trend, then you choose this. So this is a trend. When you change say some ratio of two liquids, you will get to see some trend. So then so whenever you have a series, when you want to show a trend in change, you choose similar colors. But if you want to show any say anomaly or whatever, then you can choose this color. But this color has, this plot has some more problems with color. We will come to that later. So this is the idea. So we choose left one to show a trend or series. Okay, so what about, yeah, do you see anything hidden in these lines, in these two graphs? And the title is a hint. Okay, this one is easy. Let's start with this one. So, which curve here is easily distinguishable? This one, right? And why is that?
Zooming
Huh?
scale.
So the line is thicker than all the other lines, so it's very easy to spot, right? And okay, so what about this? Which curve here is easy to distinguish? Blue one, right? And why is that standing out from other colors or other plots? So here, if you can see, blue color is different shade, and if we talk about warm and cold colors, what is the color group we are following here? Who is speaking?
Middle one is average and up and down is there are like particular things.
Yeah, you can say that. So here we use warm color for all the graphs. Only one plot which we want to highlight, we are using colder color, so that is blue. So then, so from both these examples, let's say you have a plot and you want to pinpoint one graph. So either you can make it thick or you can change the color scheme. So it will stand out from rest of the graphs.
Do the vice versa, like we can use the cool graphs and do warm.
Yeah, you can do that. You look cool. Yeah, so is this distinction easy? So if you have to highlight any plot in your, say, graph, if you have, say, 10, 12 graphs together, you want to show only one main thing, then you can use this, either thickness or color. Yeah, here, font, there is a problem. The font is not the best choice. Why is the font not good here?
No space.
Separation between.
Okay. Look at the numbers. This is okay, but numbers, maybe it's on projector, it's not that evident. Yeah, the gap is very bad, right? There, okay, there it's a bit small, but here there is no gap. So if you have this problem, what will you do?
Change the scale.
Yeah, change the scale. So maybe instead of, say, 500, 400, 300, just write 500 and 300, right? And just put a tick here so people know, but you don't have to squeeze in a lot of fonts. So is that clear, color scheme? Okay, so some people were asking about color, so let's talk about colors now. So what is the difference between, say, blue color here and blue color there?
Bright.
This one looks more bright, right? But if you look at the graph, which one looks better, the left one or the right one? Right one. Left or right? Okay, people are divided here. Okay, who says right is better?
Actually, orange in the left enhances the focus than the yellow in the right. Maybe if we have orange on the right, then we can compare better.
Okay, if we look at, say, blue, green, blue, orange, green, and all these three colors, which plot do you think is better? If you look at the whole graph, not just the blue part, which one looks better, left or right? Okay, how many of you say right? And how many of you say left? Okay, why do left people say it's left? Huh? Okay, why do people who said right think it's right?
All the three can be distinguished to the left.
Okay, visibility wise, right is good, right? But what about say color scheme? Hmm.
We have chosen blue, yellow, and green.
Hmm.
We see that circle, and blue and yellow are opposite it, so we can easily distinguish between blue, green, and yellow.
You are talking about this one or left or right?
Right one,
Right one.
yeah.
Yeah, that's true. So from the color scheme, it's complementary. So that is correct. But okay, so let's say in your thesis or publication or chapter, you have followed one color scheme, which is mostly say blue, cooler shades. Then which one will you choose? Let's say you have blue and green in most of your figures in your thesis or in that chapter in your thesis.
Yellow is closer. Right.
I think on projector it's not that evident. So if you have, let's say, color scheme which is using a lot of say blue and green, then you will use. Yeah, it's a bit hard to show on projector. Even I cannot see the difference. Huh? You are excited. Okay, let me go to this. My internet is also not working. क्या हो गया? There is some problem, right? Okay. Okay, let's do it here itself. Fill stroke. Yeah, so this is say, let's say default red in your RGB. Let's say this is pure red. I have not done anything. Then I can, so in this triangle, if you HSL, yeah, so whenever we choose colors, you have to follow a scheme. So there are many schemes. So HTML color code is one which we saw in the mermaid thing. You have a hexadecimal 6-digit thing, and there is another format called HSL. You can see this in a lot of websites also. So HSL stands for hue, saturation, and lightness. So hue is the color. I think, yeah, you can see it here clearly, right? So you make your red, green, blue, VBGU or whatever in hue, H. Then S will give you saturation. So if you make it fully saturated, it will look very bright red. Or if you make it less saturated, it will look like gray. And then lightness, you can make it dark or you can make it white or light. So usually, I think it's not that evident, but we always try to avoid like very sharp color. So full of saturation and lightness is 50. So this is some color combination which is not that good, say when you do a presentation or printing. So either you make it little bit dark or little bit light, then it looks less sharp on eyes. Is that clear? maybe in here it's not that, on projector it's not that clear, but you get the idea. So making colors which are say very sharp red or say sharp green or any default colors as you can say, they are not very good or they are not very pleasing to eyes. So either make it little bit dark or little bit light. So either you can play on the, so I have showed it in triangle, but you have to change the lightness to say uh, less than 50 or more than 50. And then saturation also you can play with it. So the difference between this blue and this blue is the same. Yeah, so let's say this is default blue which you can pick. So this is very sharp and very high contrast. But if you are using many colors, then this will stand out in front of everything else. So for example, here in this graph, you can see yellow is standing out, blue is standing out, and they will not mix very well. Even though they are say, okay, they are far in the color wheel, that blending is not that good. So if you can make it little bit light and then yellow also, let's say little bit light shade, then the blending is better. So your graph will look more coherent. If you make say everything little bit light shade or dark shade when you play with the say lightness. So for example, if everything is darker here, so I make the lightness to dark shade for all the colors, then it will look slightly more coherent. So in the left graph, I have made everything little bit lighter. So then it will look say more coherent. But if you use default colors, it will look contrast, high contrast, but then it will not say blend together with say rest of your figures or your other figures, whatever. So yeah, so that's why most of the times we don't use the default color. So in all plotting softwares like Origin, I think Excel, the default colors are slightly better. Origin, it's exactly this. So you get this at the point where your HSL L will be exactly 60, then saturation is 100. So make sure your saturation is different and lightness is other, say slightly other than 50.
Sir, at the time of printing, does brightness affect
Hmm.
those graphs?
Hmm. Yeah. Yeah. Give me 1 minute. Yeah. So when you print, if you make it lighter, it will be difficult to see. So if you print black and white, let's say you make a plot and you print it black and white, your color will be hidden. Only contrast you will see is from saturation and lightness. So even if your colors are, let's say your hue is different, but your saturation and lightness are same, you will look at the same grayscale. So if you are printing it for black and white, or let's say your journal is asking you to print say both black and white and color, then make sure your lightness and saturations are different. Then printing is not a problem. But let's say you choose all primary colors, all the default red, default green, default blue, all of them will have lightness of 50, saturation of 100. So they will look the same color. So make sure you change the lightness and saturation, especially when you are printing say black and white. Okay, so that is about color. So any questions on this?
So there is a boundary line in the graph,
Hmm.
the bar.
Okay.
Boundary line is that good or
Yeah, so what do you think? I also didn't notice it, but
distinguish or distinguishing two lines?
yeah, so Saddam, I think he raised a good point. So here in bar graphs, we have a black border, yeah, on blue and yellow. Blue one, I can see the blue one on my screen. Green one doesn't has. Yellow has. And here, yeah, green one doesn't have. Blue and orange has. So do you think having a border is good or bad? So, okay, let's say blue is a bit darker color. If we don't have a border here, it will not make much difference, right? But yellow is very light shade. Can I edit it? Okay, let's say this is yellow fill stroke. Okay, I remove this.
But the width of each bar is same, so I guess there is no need of border.
Okay, so can you see any difference between, say, CO and Li, this cobalt and lithium? What about the yellow bar? Which one is more visible? Which one is more easier to see? Cobalt, right? Yeah, so you got your answer, Saddam. So at times when we use light color, because that will blend with white, especially on projector or say for people who are 60 years old, then having the contrast with border is easy. So whenever you make lighter charts, especially say bar charts, have a black border, that is best. If you have dark bar charts, doesn't matter because it will not mix with white that well, so it's easy to see. Yellow one is a bit difficult, so having a border will make it more visible. Okay, any questions? Okay. Okay, we are running short of time. Okay, so what is the difference between these two graphs?
The legend is inside the box. The legend is
So which one do you prefer?
right one.
And why is left one not good? Huh?
Because focus goes on the legend rather than the plot.
Why is that? Yeah, you are right. Focus goes on legend, but what makes it very uh, apparent? Why is legend so visible on left side, but not on right side?
Black color.
Yeah, so I think most of you got it right. If you have black color, that is first thing most human eyes will see because that is the on white paper or white board. The biggest contrast you will see is of course in the black color. That's why all the text we write is usually dark or black. So here if you see a big black border, that is the first thing your eyes will catch. So that is a distraction in many cases. So here you can see it's not that evident, right? Because we don't have that much black lying around. The fill area for black here is much less, but here we have a big black border here. So that's why it's very distracting. So if you want a border, you can have a thin border like this, but if you have a say shadow or something which is very thick, it's very distracting. So that will make your plot a bit hard to read. So for example, if you are showing slides and you are going through presentation and you are spending 1 minute per presentation, per slide, and then if you show this graph, most people will spend maybe 3-4 seconds just looking at your black border. But if you show this graph, maybe first appearance they will see the bar and the charts, everything, the legend. So this will make difference because that is a distraction. Okay, what about if we make this black some other color? Can we make it less distracting? Okay, white is best.
That is 3D type option, but that is only 2D things because like border
Hmm.
will create the three-dimensional space for the legend information.
Okay, so will you prefer 3D plot
No, no,
or 2D?
in the 2D you should follow the 2D things for all the information.
Yeah, so I think he brought an interesting point. So if we make 2D plots, we can make elements like shadow to look like 3D. Is that good or bad? Huh? Why is bad? 3D, real world is 3D, right? Why is 3D bad?
Because we are presenting one projector to be.
If we want to highlight any specific theme,
Hmm.
then we can choose 3D themes. But if like legend is not like our main focus is the graph part,
Hmm.
so that's why we are focusing only on 2D part.
Yeah. So the main purpose of graphs or plots is not to show some artistic side. It's to show the data, right? So if you have all the 3D shadow, all these things, People will not look at the data, they will look at the shadows and everything. So that is again a distraction. So if possible, if your data is clean and visible on 2D, don't make it 3D. Keep it simple. Yeah, so that is the point here. So that is more like 3D, unnecessary. This one has less distraction, so it's all 2D. Okay, so what is the difference between these two graphs?
Color of the text.
Color of the text. So where do you see the difference?
Word recovery is green.
This is green and that is black, right? And this is also green, this is orange, this is black. So which one will you prefer? Why right one? Okay, why left? Yeah, so people who say right, I think they will say it's easy to match the font with the graph, right? Because it's orange, so I know it doesn't point to anything else. So this is green. For example, if these two are very close or say written here, so then it will be very hard to see, okay, which one is cobalt, which one is manganese. But now it's easy, if you have it green and orange, then it's easy to see. And if you have everything black, it will be a bit difficult. So most of the times you can use this, but make sure your font color is not very unreadable. So if your color is, let's say, yellow, then you cannot read your font on white background. So this is a bit darker shade of orange, it's still okay. Yeah, so if you have to use color, it's fine, but make sure it's readable. Don't use any light color. So let's say your plot is, let's say, some lighter shade of yellow or say some shade of yellow. What can you do on the font color if your plot is yellow? Huh?
We can maintain everything as black.
Yeah, so that is one option. You make everything black, or
Otherwise, we can mark arrows for the arrows and then.
yeah, you can mark arrows, you can make everything black, or you use slightly darker shade of yellow. So mix some black, so make it look like say brownish or something. Not that different from yellow, but make it a bit dark. So point is, you can play with the font colors, but the readability should not go down. If it's light yellow, you cannot read your font, then it's useless. Then it's as good as having no legend at all. Text outline. What is text outline? Huh? Okay, border of text. Yeah. So if you are using say light color like yellow, you can use the text border as black. That will also make it visible. So yes, so light colors have problem. So you have to use say black borders or use darker shades, especially when text. Okay. And okay, what is the difference between these two curves?
Near the legend only, everything is mentioned.
Huh?
In the legend only, everything is mentioned, sir, regarding the graph.
So here legend says everything, and here it's all pointed near the graph. So which one do you prefer, left or right? Okay, when will you use right? Any specific situations where right will be better?
When the number of plots are less,
Number of plots are more.
More or less?
less I guess, because
Less. Okay, what if the plots are very close to each other?
then we will use legend or structure from particular part.
Left one. Okay, so I'll tell you one scenario. If you have to print it in black and white, which one will you prefer? Right, right? If you have to print in black and white, then colors will be very difficult to distinguish. Then you have to use the right one. Or let's say if you are running out of space, that you don't have legend space, then you can use this. That is also one scenario. So if you have space, you can use legend. If you don't have space, you put everything near the plot itself. Or if you have to print black and white, then use this. Okay, so last two slides. Okay, so these are two schematics I have made. This one and this one. Only the colors are different. Which one do you prefer? Bottom or top? Bottom. Okay, how many of you say bottom? How many of you say top? Yeah, why did you say bottom?
It's conveying different types of things.
Okay, let's say these. Okay, assume this line is not there, everything is a single plot figure. Do you prefer this color scheme or this color scheme? Huh? Zoom. Okay, zoom. I cannot zoom it anymore. Yeah. Information is same. I have only changed the color. So this is everything is say orange shade. Here everything is say orange, green, blue.
Which we are conveying different types of data.
If arrows represent different stages of the process,
Hmm.
then the top.
I prefer top one because it looks consistent, right?
Information needed.
So you can argue, okay, these two are different steps. So this is all green, let's say. This is all blue. But everything is if everything is conveying same thing, then everything in one color is okay. So bottom line is, if you have one figure schematic, to make everything look coherent, use only one shade. If you have, say, multiple colors, then it's a bit distracting. If you have everything one color, it's easy to read, right? Okay, everything is part of one box. It's everything is that figure. So use colors wisely. If you have to use colors, make sure they are consistent, coherent, or in the color circle near to each other, if you want. But you can make good figures even with one color.
Sir, let's say if we are in the first step, we are doing something with copper, okay? We will use light brown. And in the bottom step, we are using some kind of like water molecule is there. Then we will use, it's better to use blue, right? Instead of using this.
So exact color is debatable. Yeah, if you have water, you have to use blue. But if possible, use one color everywhere. Okay, then this is the last slide, last photo. So what is the difference between these two? Which one do you prefer, top one or bottom one? Why do you prefer bottom? Simple. Between this line and this line, why does this line looks simple or better to you? So human eyes like symmetry. So if you have anything going left or right or say curve, it doesn't look like you cannot catch a pattern. But here you can catch a pattern easily. So that's why whenever you are making schematics, if possible, use say 90 angle everywhere. So it looks everything is horizontal or vertical in this line in this schematic. So it's very symmetric. Here it's very hard to say. And anything Say this arrow and this arrow. Which one do you prefer? Why? Yeah, this one is a bit distracting, right? So this looks more darker than your beakers, but this one is okay. So yeah, if you don't want to highlight the arrow, but you want to highlight other things, make your arrow thinner or smaller. Yeah, so that's all from our side. Anybody has any questions? Okay, let's start now. Yeah, today both the TS didn't come.